Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fashafuddin bin Muhammad Roslan. I am 2 years BNT students and from STK. So today I will be presenting about 2021 Kelana Jaya LRT collusion. So this topic was given by my lecturer, which is IRCS Mustafa Kamil bin Omran. So this program is BNT 30103 and subject name is technology rolling stock. So right now we are going to introduction part. In introduction part, we can see a little of picture that have been taken during an accident. So we can see how bad the impact from the collision. So we can see the face interference of LRT 181 and 240. So we go deep to the introduction part. Who owns the Kelana Jaya? Prasana Malaysia Berhad owns and manage the Kelana Jaya LRT systems. So the objective of this project is we want to analyze costs and propose engineering solutions and how it be operate. The line is fully automated and operated by Rapid Rail using the Bombardier ART technology. So TR40 was carrying passengers while TR81 was under manual control. This incident exposed a major concerns about the safety and reliability of automated urban rails networks. And right now we are going to the accident overview. So we can see TR81 re-enter the mainline manual after repair. So uh, we can see the driven back onto the main line after undergoing repairs. So, but unfortunately, the automatic train control system failed to detect its actual position and mistakenly believed it was stationary. And meanwhile, TR40 was allowed to continue the same track, so it's resulting in a head-on crash at around 40 kilometer per hour. So the result was over 200 injuries, including the several critical case. And we can see that the impact is very bad behind the accidents. So right now we are going to the key engineering failures. We can see the point which is the ATC failed to track manual train movements, and which is the ATC system could not track the TR81 once it was under manual control. So there was no real-time detection in place for manual movement. Additionally, the hostler and OCC had no active communications. So the real communication or vividly communication between the LRT was not be prepared well, and even though the procedures existed, they were not followed or enforced. And we can see there is the first setup that not improve the efficiency of the LRT. And right now we go to the problem identifications. So in problem identification we can see the point which is talk about the manual blind spot. So manual blind spot, um, the first major flaw was the blind spot created when the system could not detect the manual movement of the RA1. So the CBTC system continue to show the train as a stationary, and there were no backup systems like GPS or track sensor to confirm the positions. This create a dangerous situations where one train was invisible to the control center. And the next key is about the SOP and human reliability. So we can see the hostler failed to confirm the direction of movement, OCC didn't check if the track was clear before allowing the TR40 to proceed. Although the SOPs existed, they weren't followed properly. No verification system was in place to double check human decisions. And the next was signal interlock gaps. No automatic brake or interlock integrated, and system didn't prevent the TR40 and TR81 from sharing track. So the system didn't activate the emergency brakes and trains from entering the same track segments. So there were also no access counters of vehicles or detect unauthorized movements. So this show a serious gap in safety system. So the next point is outdated equipment. VOBC failure on GR81 and obsolete tachometers provide no speed and or location data. When the VOBC failed and the tachometers were no longer supported by manufacturer, we can see the actual speed. We can detect how the speed train properly. Without this equipment, the control system could not track the location and effectively making the train is invisible. And right now, we are going to the solutions to solve the problem that we have identified. So the first point, we talk about the redundant detection system. So what is about the redundant detection systems? We will install the access counter and track circuits. We need this redundant system because access counter and track circuit can serve as a physical verifiers on the train locations. This system operate independently from onboard electronics and are already used in European railways to provide the fail-safe trackings. And the second solution was reverse movement detections, software to logic detect the wrong direction movement. So the software can detect the reverse or unassigned movement. If a train moves in a wrong directions, the system should trigger emergency braking. In even in manual mode, the route should be verified before movement is allowed. This reduces the risk of conflict between the train operations. And the next solution is OCC interference upgrade. We will use AI to predict conflict paths because this generation the AI is increasing in the world. So the OCC interference should be upgraded to provide the real-time visual alert using AI. The system can track all trains and predict possible collisions before allowing a train to move manually. The OCC should confirm the directions and route to prevent the errors. And then the solution is digital SOP informants. To enforce SOP, we should digitalize them. Hustler can use tablets to follow step by step and step by step about the checklist. All steps are logged, times, tempered, and tracked. Communication should be recorded to ensure the accountability and allow post-incident reviews. And lastly is fail-safe hardware. We need hardware-based fail-safe because physical device like trip, cogs, or zonal isolation breaks can act independently of software. If a train enters a restricted zone, it will be stopped automatically, and this approach is already in use countries like Japan and Singapore. So right now, the solution is done. So we are going to the conclusion of this project. We want to we want to conclude this project. So in conclusion, the collision was the result of multiple failures from the blind spot in the system to outdated equipment and effective procedures. But with proper engineering interventions such as redundant detection, upgrade software, and stronger SOP enforcement, this can be prevented in the future. Safety is very important for the customer service in transportations. If we are not enhance the customer safety, how we can make the trust from the customer. So the business or transportation service cannot be operate well and increase like the European country. We can see the European country, they use the public transport, and we can see also invest the right technology and training. Safety cannot be compromised. And finally, this case is strong reminder of the ethical responsibility engineers have to protect life. Accountability and foresight must always guide system design in public transport. So that's all from me about the presentation of this project. Thank you very much and welcome.